Hello, we are Team 7347, and this is our project progress at the end of Sprint 4. Our team is working on a software reverse engineering framework designed to streamline and unify the malware analysis process onto one platform. Our goal for this sprint was to complete implementation of the retargetable decompiler plugin called RetDeck, continue to work on CLI symbolic execution in a Docker container, and bring our project closer to being deliverable with increased documentation and examples. When viewing the graph view of our application, we wanted researchers to be able to visually scan through the disassembled blocks and determine which are taint sources and taint sinks. We added a menu option that highlights all of the blocks which contain taint sources or sinks. This functionality drastically increases the ease of finding sinks and sources. Previously, researchers would have to read through a list of sources and sinks, and then look through the disassembled code manually. Now users can scroll through the graph as usual and see all the taint sources and sinks at will. By increasing the visibility of sources and sinks, we conform to Jacob Nielsen's recognition rather than recall principle. This sprint, we made large steps towards a final, polished deliverable for our client, and are well on our way to exploring our stretch goals. One of our goals was to publish a new GitHub repository with a model for third-party collaboration, which is submoduled as Binja Auxiliary. This submodule includes significant documentation as well as code, API, and pull request examples. This submodule also includes window forwarding binary ninja container runner, which is most useful for safety during malware analysis and simplifying the installation of plugin dependencies. We spent a great amount of time working on input validation and help menus to make the end user's experience as safe and simple as possible. For this sprint, we have finished implementing the retargetable decompiler service plugin for Binary Ninja called RetDeck. This allows you to decompile both binaries or functions from the Binary Ninja interface by selecting either the whole binary or specific functions. This will send the file over to our local Docker container holding the RetDeck decompilation code and send back the decompiled source code. We have created a Python API to both send and receive information from and to the container service, as well as creating an automated script to create the Docker container with one simple command.